to test your understanding. Okay. Right, next, if you have two complex number and you want to perform addition, subtraction and multiplication for the two complex number, okay, you can apply this property. Okay, for addition and subtraction, okay, the real part of the two complex number must be added together and cannot be mixed with the imaginary part. So what I mean here is, when you want to perform addition and subtraction, the real part will add with the real part, the imaginary part will add with the imaginary part. Okay, so A with C, B with D. Okay, so you cannot mix real part and the imaginary part. Same goes to subtraction. If you minus, okay, subtraction or minus two complex number, okay, you will minus the real part of the first complex number with the real part of the second complex number. So A minus C, okay, plus with B minus D. Okay, so remember it is always plus in the middle here because this is the way we write standard form of complex number, A plus BI. Okay, so plus. Okay, it will be negative Z equal to A minus BI, okay, whenever your B is negative. Okay. Understand? Okay, for multiplication, you will multiply as usual. Okay, where this is Z1 multiplied with Z2 is equal to A plus BI. Okay, it is a little bit special because for multiplication, you can multiply as usual. Okay, where A multiply with C and then A multiply with the imaginary part. Okay, it's okay because when involved with multiplication, you will get a square, okay, square I, where you can simplify towards the end. Alright, so this can give you AC plus ADI. Alright, while for B, okay, multiply that will give you BCI, and this B multiply with D, that will give you BD, and I multiply with I, that will give you I square. Okay, so you simplify this become AC plus ADI plus BCI plus BD. What is I squared? I squared is equivalent to 1 minus 1. Alright, so minus 1. Okay, so this is equivalent to AC minus, okay, minus, because BD multiply with minus 1, that will give you minus BD. Okay, so the imaginary part is these two. Okay, plus I put I outside the bracket, so this will give you AD plus BC. Okay, so that is how you get this equation. So this is just a piece of cake of an example from addition and subtraction as well as the multiplication. So I have shown you how we do this theoretically. So for practical part, I leave this for you. Okay, so the answer is here. You can try and check whether your answer is correct or wrong. Okay. Do you still remember what is conjugate? Okay, conjugate of the complex number. Okay, right. If you have complex number equal to a plus bi, the conjugate of this complex number that we represent it as z bar. Okay, z bar means z conjugate is actually equivalent to the a minus bi. Okay, so only the imaginary part change the sign. Okay, so the conjugate of a complex number changes the sign of the imaginary part only. Okay, so you do nothing to the real part here. Okay, so the sign bar on top of the complex number here means you change the sign of the imaginary part. Okay, so if it is positive, the conjugate of the imaginary conjugate of a complex number, we change the sign of the complex imaginary part to become negative. Okay, if your z is a minus bi, the conjugate of your z will change the sign of the imaginary part only. It will become e plus bi. Okay, so remember, conjugate changes the sign of imaginary part only. Okay, so if we plot it on the Cartesian plane, it will reflect the point z on the real axis. So real axis will become the mirror. Okay, let us look at the next slide. Okay, so if this is your z, okay, your complex number z, which is equal to 2 plus 3i, okay, this means that this is our A and this is our B. Okay, our A, which is the real part, is plotted on the x-axis. Okay, so B is our imaginary part, is plotted on the y-axis. So this will give us coordinate 2, 3 because we have positive b. Okay, so when we plot this into the Cartesian coordinate, where is 2, 3? 2, 3 is 2 is here, 3 is here, so this is our z. Okay, so what is the conjugate for our z here? Conjugate of our z here, it is z bar. Don't forget to write z bar because that reflects the conjugate. Okay, so it will change only the sign of the imaginary part. Okay, so since the sign is positive, when we conjugate the complex number, it will change to negative 3i. Now the coordinate for the conjugate is 2, negative 3. Okay, so where is the point of the conjugate? It is 2 for our x and negative 3 for our y. Okay, so this is the point of our conjugate. Okay, so you see, the conjugate will reflect on the real axis. Okay, so it is like a mirror. Okay, so our real axis, okay, our x-axis will be like a mirror. It will reflect the our complex number, okay, on the Cartesian plane. So I hope you can understand all the explanation that I've made before in the previous slide. Okay, so this is just a recall, okay, to what you have known about complex number before. Alright, so next we proceed with the example of finding the conjugate for the complex number. Alright, so always remember conjugate is the changing involved with a changing of sign of the imaginary part. So for A, your Z conjugate is 1 minus I. Okay, so change this part. Right, so for this one, Z is equal to 2 minus 3I. So Z conjugate is equal to change the imaginary part signs. Okay, that will give us 2 plus 3I. Okay, so C, our Z is equal to minus 16. Okay, so for C, we only have the real part only. So we have 0 imaginary part, right? So we have none for imaginary. So the conjugate of C, the imaginary part, is minus 16. Okay, because it won't change anything because we don't have the imaginary part. Alright, while for D, okay, we have 0 for real part, but we have 8I for imaginary part. Okay, since conjugate involved with changing the sign of the imaginary part, thus this will change positive 8I to negative 8I. Alright. Right, so here is the list of properties of conjugate of complex number that you can apply to ease or to helps you to solve the application and the calculation that involve complex number. Alright, so if you have Z, okay, the double conjugate, okay, of Z is equal to Z itself. Alright, okay, for example, if you have a Z equal to 1 minus I, okay, the conjugate of Z is equal to 1 minus I. And if you find the conjugate once again from this conjugate, means the double conjugate, okay, this will give you back your Z. 1 plus I. Okay, so that's why it says here Z is equal to the double conjugate of itself. So this is equal to that. Right? Okay, if you want to find the summation of Z1 plus with Z2, and then you find the conjugate of it, right? That is equivalent to you find the conjugate of the complex number first, okay? And then you add them later, okay? What it means here, if you have Z1 equal to 1 plus I and Z2 is equal to 2 plus I. Okay, if you want to do summation, okay, you have two ways. Either you sum Z1 with Z2 first, that will give you 3 plus 2I, and then you find the conjugate of this Z1 plus Z2, okay, that will give you 3 minus 2I, right? Okay, so instead of doing the summation first and find the conjugate, You can also find the conjugate individually. Okay, means you find the conjugate of Z1 first, which is 1 minus I, and then find the conjugate of Z2, which is 2 minus I, and then you add them separately. Okay, Z1 plus Z2 conjugate, that will give you 1 plus 2, that will give you 3. So minus 1 plus with minus 1 plus minus I plus with minus I, that will give you minus 2I. You see, this property is equivalent to that property. Okay, so same goes to subtraction, multiplication. Okay, you can find the complex number individually first and then perform the operation. Okay, so all these properties will help you to solve the operation of complex number. Okay, just to simplify things so that you don't have to go through the hard process. Okay, so 1 over the conjugate of z, that is equivalent. You find the fraction first, okay, the division first, 1 over the z, and then find the conjugate later. Alright, so the complex number to the power of n, okay, conjugate of complex number z to the power of n is equivalent to the conjugate of the complex number. Okay, find the conjugate of the complex number first and then find the power. Alright, where n is always the positive number. Okay, so n is integer lah, 1, 2, 3, 4, and so on. Okay, right, so if you perform the addition of z with the conjugate, okay, its conjugate, divide by 2, it will give you the real part. Okay, while if you perform the subtraction of z with its conjugate, okay, that will give you the imaginary part. Okay, so I'll show you how you get this property. Right, let us take a simple simple example. Okay, so z plus with its conjugate. Okay, so we take from here. This is our z and this is our conjugate. Okay, so z equal to 1 plus I. So we have the conjugate here, which is 1 minus I. Okay, so we perform the addition of the complex number with its conjugate here. Okay, so z plus with z conjugate, its conjugate, that will give you 2. Okay, what is this? Plus I, okay, plus with minus I, that will give you 0 imaginary part, right? Okay, so from z plus z conjugate equal to 2, okay, if we bring 2 to this side, that will leave us with this. Okay, so where this means we only have the real part of z. Okay, we only have the real part. We don't have the imaginary part at all. While for subtraction, so if we subtract this, okay, this will give us z minus z bar. Okay, 1 minus 1, we have 0 for real part. 1 minus 1 is 0. While for this one, I minus with minus, that will give you 2i. Okay, so this this left us with the imaginary. We have none. We have 0 for real, but we have for only imaginary. Okay, so if we bring these two I to there, okay, this is z minus z2 equal to 2I. Okay, z minus z divided by 2I will leave us 0. Okay, so this means only imaginary part. Okay. Okay, among all the operation that involve complex number, okay, only division of complex number is a little bit different than other mathematical operation. Okay, where the division of complex number will involve with the conjugate. Okay, so let's say if you have the two complex number z1 and z2 here, okay, z1 and z2 here, division of z1 and z2 is it means that a plus bi divide with c plus di. Alright, so in order to solve this equation, okay, we need to multiply this with the conjugate. Conjugate of what? We have nominator here and we have denominator. Excuse my handwriting, okay. So you have numerator here and you have denominator. Okay, so yang ni yang atas, this is yang bawah. Okay, pembawah. Okay, so the conjugate that you need to multiply is the conjugate of denominator. Okay, conjugate of this one. Okay, so both bottom part and the upper part you multiply with the conjugate of denominator. Okay, and then you will perform the standard multiplication of two complex number. Okay, and by multiplying the conjugate of denominator, okay, towards the end, okay, the product of it will leave us with real number for the denominator. Okay, so that is the purpose why we multiply with conjugate, so that at the end we will have in the form of a plus bi, standard form of complex number, right? Okay, I will show you one example and I will leave the rest of the example for you to try at home. Okay, so let us take A. Okay, so to solve this division, okay, z is equal to 3 plus I divided by 2 minus I. So we will multiply this with the conjugate of denominator. So this is the denominator, 2 minus I. So it means here, the conjugate of denominator here, okay, conjugate changes the sign of the imaginary part. So we have 2 plus I. Okay, same goes to the bottom, 2 plus I. Okay, so we multiply these two complex number as usual. Okay, that will give us 3 times 2 is 6. 3 times I is 3I. I times 2 is 2I. I times I is I squared. So I squared. Okay, now let us perform the product for the bottom part. Okay, 2 times 2 is 4. 2 times with I is 2i. Okay, negative I times 2 is negative 2i. Negative I multiply with I, that will give you I negative I squared. Okay, so by multiplying the denominator with its conjugate, will vanish this one. Okay, so 2i minus 2i become 0. Okay, so this one can be replaced by 4 minus with, remember what is I squared? I squared is negative 1. Okay, so we solve for the bottom, the upper part. So this is 6. This is 5. And what is that? That is also minus 1. Okay, solve it again. That will give you 6 minus, that is 5 plus 5i over, this is 4 minus with minus 1, that is 5. Okay, so take 5 out, that will leave you 1 plus I. Okay, factor the 5 here out, that will leave in the bracket 1 plus I. So over 5. Okay, so cancel out 5, that will leave us with only 1 plus I. Okay, so ta-da! 1 plus I. Okay, so for B and C, you need to simplify this first. Okay, so remember the first few slides. Okay, I have shown you how to simplify the imaginary part. So apply that, simplify first until you have in the form, in the standard form. Okay, only I without power. Okay, that is standard form. And then this will leave you with C, D, I. Only then you can proceed with multiplying with the conjugate of denominator. Okay, so you follow the process that I've shown you for the first example. Okay, so for this one, okay, you have the fraction, you have the division, okay, 2 division, and you also have the subtraction. So you have 2 ways here, whether you solve the minus operation first and then followed with the conjugate. Okay, multiplication of the conjugate. So this is the first choice. Or the second choice, you find the conjugate, you do the conjugate, means you multiply conjugate for both. For both, mean for this one and for this one. Okay, and then you perform the subtraction operation later. Okay, so you can try both. That should give you equal or same answer. Okay, so it doesn't matter how you choose it. Okay, right, that's all for our first lecture. So that marks the end of our first lecture. Okay, it is more to introduction, to recall back what you have learned in the previous level, okay, during your matriculation or during your polytechnics time and so on. All right, and even it is not too difficult, right? Okay. Right, so what you can do here, okay, to practice more, okay, go to Google Classroom. Okay, I will upload the tutorial for chapter 1. Okay, download the tutorial. Okay, there are a lot of questions there. Okay, but according to what we have learned today, okay, from the first slide to the 25th slide, okay, you can already perform, you can start solving question 1 until 11 if I'm not mistaken. Okay, I will check that out and we'll keep you informed in our WhatsApp group. Okay, so thank you for listening. I hope you enjoy this lecture. And if you have any problem that you don't understand or you need further explanation, don't hesitate to ask me. Okay, you can ask in the WhatsApp group or you can DM me. Alright, personally, it's okay. Okay, right, see you in the next lecture. Thank you very much.